while ago, I received a rather uninformed comment about game engines and that writing your own game engine isn't really all that hard or complex. And I figured that would actually make a good video where I show the subscribers the hierarchy and all the components that are involved in making a game engine for a mobile game. Because I've never really shown sort of the source or all the components that go into making a game, and also to disprove these statements. For instance, that you can look at Doom's source code and implement an engine. Nothing could be further from the truth. Doom's source code is actually more complicated than my game engine, so it's kind of ridiculous to say that you could look at that engine and then roll your own. It just doesn't work that way. And the same with the statements where I guess he's looked at Chernov's guide. I don't know what that is on making a game engine. This game engine writing, it's a contact sport. You learn by doing. You don't learn by watching stuff. But anyways, in the next part of this video, I'm going to disprove these statements by just showing the sheer volume of code that you have to write and get working correctly just to get something on the screen. So that's what I'll show in the next part of the video, and I think it'll be informative for viewers to see what makes up a game engine. So the first thing you're going to need to do is write some sort of plugin to export the models and meshes from whatever tool the artists are using into some sort of custom format that you can use in your engine. So this is a plugin that I wrote for Maya, and we'll just go through a bit of the files, just have a look see. So it's not that bad. I've managed to use some classes that I had in the engine, but it's not too bad. Of course, you're going to have to go through and understand the data structures used by whatever API that you're provided with for the modeling tool to extract the data that you need. And after that, you'll have to export into some sort of custom format for static and skin meshes, as well as some sort of level optimized data mesh, which of course you can figure out. You'll also need to come up with a UI so the artist can use the exporter, because you don't want to expose some sort of math or low-level functioning of your plugin. You want to give it a nice interface. So for example, here I have the interface that I use, and again, it hides most of the details, so all the artist has to do is select the options of what he wants to export. So a static mesh, collision meshes, animation, and camera track animations. It depends on what they do, and then they can select the options. So again, this isn't too bad, but again, this doesn't get you the engine. This just gets you the data out of Maya and into some custom format, which again, you're going to have to come up with the custom data format, so that'll be dependent on what you need your engine to do. So again, you also will need one for skin meshes that will process the skeleton into something your engine can understand. So again, that's a little bit different than a static mesh because the bones and the skeleton hierarchy is involved. And the final thing you'll need to do is export level meshes into some sort of optimized scene mesh that your engine can render. And you do that partly because it gives you a big speed up. I export these into a format that is optimized for rendering these sort of endless runner sorts of meshes. So I gain huge speed ups by taking that into consideration in my engine. So that's pretty much what you'll first need to do, is write some sort of exporter and debug it to make sure it works. Again, I'll go back to the code. Here, the hierarchy. It's not too bad, not a lot of files. But again, you need to know how to extract the data from whatever modeling package that you're working with. And again, you can read through the APIs. And the next thing you're going to need to do is write an editor, a level editor. Now you can get away with this by using the modeling package, such as Maya, as your level editor. But sometimes there's a huge advantage to using the level editor. But let's just look at this quickly. So here you can see it's getting much more complicated. And here's some UI for Qt, which is what I used as my UI for Windows, the Windows tool. And again, while this isn't code, it's just resources. Again, keeps going. So as you can see, this is getting more complicated, and I'll stop right there. I'm not going to show the rest of it because it's actually the engine that I use in the mobile game, so I'll show that later. But again, one of the tricky things that doesn't make writing engines simple is it needs to be portable. This code you're seeing here is actually the code that I run on my mobile game, and the only difference is, since we're running in Windows, I have a DirectX 9 driver, which is pretty old, but it works. So I didn't up the version to support something else, when for this editor it works well enough. And the rest of the engine is what I use in the mobile game. So writing portable code can get a little tricky, and I'll show the editor now. And here you can see what that code gets you. So now you have the editor where you can place your assets and just do some tests. So again, you can get away without not having to do this, but if you have it, it makes creating the assets a heck of a lot easier, and especially for the artist, because they can see roughly how it would look in game. So again, another big advantage to doing this. But again, even after writing all this code, you're still not close to the game. You don't have the game, and you don't have the engine, and that's what I'll show in the next part of this video. Just to prove again that it's not as easy as some people make it out to be. It does take a lot of effort, and I'll show that in the other part of this video, where you can see how much code is actually involved. All right, here we'll get to the meat and potatoes, and then I'll show the sort of hierarchy of all the code that I've had to write for the engine. So first it'll start with the game code, which is up top here. So I'll stop at certain parts, and I'll just skip over some. Here's the component. I use an entity component system design pattern to manage the code for running the game. So this manages the enemy knights, the player, the overlord, and even the birds you see flying around are used with this design pattern. So as you can see, quite a few components to get that up and running, but it supports everything in the game that you would need. And I use the entity component design pattern because I just want to keep my entity classes really simple. And the entity classes are just composed of various components. And this way you just avoid really complicated inheritance chains, and it just keeps everything nice and simple. Unfortunately, when I did this, there wasn't much information available online on how to implement this, so I had to write all this myself based on some documents I managed to get from the internet. So I'm sure now there's probably some sort of middleware that you can use that'll make this much easier. But as you can see, even the trains use the entity component system. And that makes it really simple for your entity classes. Here are my entities. It's just the game entity, overlord, and the player. And I could have put all those into one class, but I wanted to play it safe just in case. So I split it up into 3 classes. But if I had to do it over again, it would have been just one class. So some more game classes. The UI. So here's my UI. If I had time, or if I had another developer, I never would have done it like this. I would have written a tool that would, some artist could arrange the UI components on the screen and then export it to some custom UI format that then the engine would load and process. But unfortunately, that would delay me even more. So I chose this other method instead, which is I just have some base classes for the UI, and I wrote the code myself to leverage those classes. Again, not ideal, but sometimes you've got to make decisions, and I just didn't want to write another tool and be even more delayed. So that's what I did. And as you can see, even for this game, the UI is pretty involved. So that was a sizable chunk. But again, it's fairly easy to do. Once I had the base components, I could just mix and match and pump them out. But still, there's quite a few of them. As you can see, it just keeps going and going without stop. But eventually, I managed to finish it. But again, that should start getting you, some sort of idea of, game engines. It's not that simple, and something that's simple is that the UI for this game, it involves quite a bit of code. Now, the code isn't difficult, but again, you've got to design it properly. It's got to be portable. It's got to be efficient. And this is just the high-level code. Then there's low-level code on which this higher-level UI code is based. So here's just some frameworks that I need for the game. And let's see what else. Oh yeah, I use my own memory allocators, so that way when the game is running, I can track which parts of the code are allocating what, and that way I can see if there's any issues where if any part of the engine is hogging too much memory, or if there's overwrites or leaks in the memory. So that's another thing I had to write, which it helps me make sure that there's no issues with memory since I'm using C++. So I'm responsible for allocating memory and deallocating it. It's not garbage collected. And here's the animation system. Again, it uses the entity component system. So any entity that needs animation has this component. Basic camera classes, base classes for saving cloud saves, in this case just iOS, collision detection. Here I use convex collision brushes, which is kind of an older way of doing things, but it's very efficient. So for mobile games and the type of games that I'm using, that was more than enough. But I also have oriented bounding boxes, which again, this isn't used in the game, but it's in other projects I've used that. Actually, I think I'm using this for collision detection in the level editor for point and click. So it's at least using the level editor. And here are the base classes for the entity component system. So these are the interfaces that you use to build the higher level game components that I showed up above. Controller man, I never used that. That was for another project. And then just some basic classes. More these are entity components that you can use in your higher level classes. And I see, for example, I support CPU skinned or GPU skinned renderable components, and you can mix and match in the engine at the same time. So if you feel that you're using too much of the GPU, you can switch to the CPU and vice versa. File system. I use my own custom file system for the game. So yeah, I had to write another tool, which I didn't show. There's no point. But it just saves a custom data format that I then fish out all the data using a memory map file. Fmod sound support. Oh, frame commands. Man, this is showing. This at one point I wanted to have a multi-threaded rendering engine, and I did get it working, but it introduced one frame of lag, and I tested with a couple of players, and they said I don't notice anything. It's fine with me. But I could tell that it was lagging. It just really bothered me. And for this type of game, you don't really need a multi-threaded rendering engine. That was, I guess, when I had more energy at the start of the project, and everyone, that was the thing to have. So I said, oh, I need to have that too. But in the end, it was dropped. Generic. This, again, it's not used in the code. This was just to get me started. I had a generic scene manager because I hadn't planned what the eventual scene manager was supposed to be. So I used the generic one just to get me up and running. And below here, we have the Opengl Es render system, which hides all the details with Opengl ES, which I still support because there's older phones out there that's all they support, so it's good to have. But again, quite involved in getting everything set up so that it's hardware independent. So with that design, I can either switch from Opengl ES to Direct3D 9 as I did in the level editor, and the engine won't care. So that's what I said about being careful to make sure your code is portable. Some math routines that every engine has. And here's the metal render system. This is the latest rendering API for Apple. So when that came out, I made sure to implement that. So on the newer phones, you'll be on the metal render system. But again, quite a few files needed to get that up and going. And here we're the particle system. I use quite a bit of this in the game, although it really doesn't look like it, but I do. Although not every, I have a general set of emitters and effectors. They're not all used. General rendering classes for my materials, meshes. So that one's also quite involved. Resource management. This is the interface for the scene manager. So if the generic scene manager that I described above implements this base scene manager, that way you can switch between scene managers flawlessly and the engine will continue to work. Shadow manager. Eventually I had supported cascaded shadow maps, but I dropped that. The casual players got confused. They said, why is a ghost following my character? And I got tired of explaining that it's a real-time shadow, so I did a blob shadow instead. But if I wanted, I can swap between shadow managers, and again, the engine will be none the wiser. Base classes for supporting sound. The store. Some classes for threading. That's another thing. When you write your engine, the modern engines have to support processors that have more than one core because it's just really advantageous. That's one of the reasons why I can render, the characters on the screen and have them fully animated and shattering, and I won't drop frames even on an iPhone 5. And part of that is multi-threading, and the other part is because I wrote that part of the code in assembly language. And here are the base classes for the UI. Again, not that many. And I leverage all these components up above in the UI classes that I showed before. So everything for the UI is based on these small files. But again, you have to sit there and think about what you need to use and make it as efficient as possible, because you don't want to be doing a lot of rendering with your UI. So you don't want to be optimizing your 3D rendering and then lose all that optimization by not being careful with how you render the UI. These are some assembly routines that I use in the engine. And here's the scene manager. This is once I got my bearings, this is the scene manager that I use in the Endless Runner game. So as you can see, this one is optimized to render the endless runner geometry for the level as efficiently as possible with as many tricks as I can come up as possible. So as you can see, it's quite complex, or at least there's a lot of files and a lot of optimizations. Probably eventually I should go in here and start cleaning some things up, but that's where I gain the bulk of my rendering advantages, is using a custom renderer for the type of game that I'm using. And again, I can swap scene managers seamlessly, and the engine will it'll be none the wiser. So again, that's right at the end of the code. But as you can see, as we start scrolling through here, I guess you're starting to get an idea of the amount of code you're going to have to write and maintain on top of that as a single developer, should you decide to write your own engine. So it's not as easy as that poster originally stated. Or at least, you know what? It isn't for me, and it certainly isn't for people I've worked with in the industry. This is actually quite difficult, and it's not only writing all these components. The trick is to have all the components that make the engine work seamlessly and be self-contained in order to eliminate any interdependencies between the components. Because if different parts of the engine know about different other parts of the engine, your code complexity is just going to explode, and you're not going to be able to maintain this. And the other thing what'll happen is you'll start making changes in some part of the engine, and it'll break other parts of the engine that depend on how it used to be. So design is critical in writing your engine. And now that you can see just how much is involved, it's a daunting task. It's even, I have a lot of problems sometimes when I have to start to get my bearings of what I need to do and to make sure that it won't affect other parts of the engine. And yeah, it's that alone is a work unto itself, just designing everything to make sure that the components are self-contained and everything works flawlessly and knows how to communicate throughout the engine so that it's maintainable by one person. So yeah, in theory, writing an individual part of this engine would be easy, but that doesn't get you a game. What gets you a game is writing everything and having it work flawlessly with no bugs. So hopefully this is a good summary of the framework that I've used to make this game. And I've shown some of the software that you need, or at least that I needed to build this engine. And probably in the future, I'll offer some tips or advice on how to go. If you were to start from scratch, what do you need to do to get to a finished engine? Like what materials you could look at, what books, how to get started, because that's the other thing. Even writing you don't start by writing an engine. You'll fail if you don't have experience. Starting to write an engine from scratch is guaranteed failure. That's not how you start. So I'll show at least the process that I went through that got me to this stage. And even myself, I'm still learning as I go along, and I'm always improving this engine, either refactoring code. Even now that I've seen some of this code, I've already gotten ideas. Oh, I could clean this up. But I'll get to that eventually. So hopefully that was enlightening, because I don't see a lot of people, at least not indie developers, showing sort of the framework of their engines. And I also did that to refute that comment that poster made about this being not that hard, or that I'm over exaggerating the complexity. So at least I showed some proof saying I'm not over exaggerating the complexity. It's quite complicated, and to be honest, this engine is not that complicated. I've worked on engines that are millions of lines long, and with multiple programmers working on one specific part. And whenever we had to hire an engine programmer, everyone would shudder because we knew it was going to be a really long process until someone showed up with just even the experience of how to get started. These people aren't walking around in droves, which also reinforces the point. If it was so easy to write engines, I don't understand why we had such a hard time finding engine programmers. It was like really difficult. We would even does anyone know anybody? Like we'll pay bonuses. So hopefully this will give people an idea of what's involved. And yeah, I'll do the next video when I can. Thanks and bye.